Hi, this is Andy from Aquatic Source for Michigan Pool News. This month we're talking about variable frequency drives that are used on swimming pools to save the energy and cut the cost of the operating of the swimming pool. Here we have an H2 flow controller. This controller is mounted on a bypass panel so that the pump can be run manual into the old original 100% or 60 hertz, running it at full speed of the 1750 RPM of that motor. We have a drive that this controller sends in, and we set up the amount of RPMs we're using and the flow rate that we want to maintain. This particular job is set up for 560 gallons a minute, so we have a flow meter that's going to keep the pump ramped up to 560 gallons a minute. To turn the unit on, we push the run command. After we've programmed it, the pump has a slow start or a soft start, so it gradually starts increasing the RPMs, at the same time showing the volume of gallons per minute going by. It could take up to 30 seconds to a minute to get up to the RPMs that you wanted in the flow rate. This is telling me that we set the flow rate right around 560 gallons a minute. The pump, instead of running 1750 RPMs, it's running 1620. We're at 90% efficiency on the motor, and it's using 8,542 watts. You turn the unit off, you hit the stop button, the pump will slowly slow down. To turn the VFD off, we have an off, which will completely turn the whole system down. It takes about 30 seconds to kill the power on the unit. The drive goes off, and then this will go off. Turn it back on in case of a power failure. Turn it back on. The screen will boot up. Once it comes online, you hit the auto run, and the pump will slowly slow start or soft start back up to the RPMs that we set up. On the original installation, when these pumps were put in, all pumps have a discharge valve on the top of the pump, and you use that for throttling to maintain gallons per minute. With a VFD or a drive, we open the valve all the way up so we slow the motor down instead of restricting the flow of the valve. If for some reason you have a problem with the drive, there is a bypass panel built into it, so you can run either pump A or pump B, or you can run it at the original 60 hertz or full speed. To do that, you can shut the unit off in case you had a problem. Let the motor stop, and you can tell on this because the amp load will drop down to pretty close to zero, like 0.2 amps. And that's on the drive. Once it's stopped, turn the key to the off, let it power down. When it powers down, we're going to go over to the pump, and we're going to turn the throttling valve to the old setting, and that's how you will adjust the flow rate. And there is the old flow meter mounted on the wall. So I'm going to walk over and change the valve manually. And by the way, there's the flow meter we put on the line to maintain flow rate based on flow, and it ramps up the pump and down. If the filter gets dirty, the pump will ramp up to 5% above where the set point is. Now that we've got the valve set, we'll go back and turn it on bypass. We are on pump A or pump B, whichever. Right now we're using pump B. When we turn it to bypass, it'll automatically start the motor. Now we're running at the original RPM of 1750, and the flow meter on the wall is telling us the gallons per minute, and you adjust your throttling valve to maintain flow rate. When you want to turn the drive back on, again, turn the key to the off position, open the throttling valve back up, back to 100%. Turn the key back to VFD, which now puts it back into the drive. It will boot up. Once it's booted up, hit the auto run. As it starts ramping up, we'll see the amp on the drive start going up, showing you the amp draw on the motor. This motor originally is set up for 17.8 amps at full power. We're actually only using 15.2 amps to do the same job that we were throttling it down before. We have an energy screen on this. When we push the energy, this tells us how much power it was used the original way, without a drive. And now we're comparing what it was using originally to the drive, and it tells us how much power we're using. Here it says that we're running, the pump has been running on a drive for 1,670 hours, and we've saved $1,332 just because of the kilowatts it's saved by using the drive. Get back to the main screen. You're there, and stop it again, and it's hitting the stop. Again, this is Andy from Aquatic Source for Michigan Pool News. Thank you.